Welcome back, everybody. So today we're going to go over the qualities of an experiment. For many of you, this is going to be review. And by many of you, I mean those of you who read previous chapters, who watched the previous videos, because we've gone over much of this, at least these few first slides. And you're going to see it's familiar with what we reviewed regarding the three requirements for a causal claim. Actually, it's the same thing. So let's start going over this, and we're going to actually go over it in a little bit more detail, especially establishing internal validity. Okay, so to claim, to make a causal claim, you have to establish covariance, temporal precedence, and you have to make a good argument showing that you've established internal validity. That third one is a bit more difficult to establish, but we're going to go over what you can do to help establish your internal validity. So the first thing you want to keep in mind is covariance. Now, just to kind of connect this to what we reviewed before, covariance when dealing with two quantitative variables and bivariate correlations includes two variables either going up together, going down together, or an inverse relationship. As one goes up, the other goes down, right? So that's covariance. Here it looks a little different because we're dealing with a categorical variable, so keep that in mind. It looks a little different. It's the same thing, but I'm going to explain it in a different way, okay? So, but just keep in mind, it's the same principle. So covariance in this type of example that you see in the bar graph, right? When you're comparing two groups, in this situation, what you want to see is that overall, there's a difference between the two groups. Now that might sound too simple, and in a way it is, but let me get more into it. So in this example, you have stereotype threat, or a group that experienced stereotype threat, and a group that was in the control condition, they did not experience stereotype threat. And then you have their score. Now, this is a math test, and the participants were all female participants. And you can see here that overall, the female participants in the stereotype threat condition scored lower than the participants in the control condition. This is covariance. When you have the stereotype threat there, it's a lower score than when you don't have it. So in this situation, that's what you're looking for. You're looking for a difference between the groups. Now, given that the difference, it's going to vary depending on what you're studying. So for example, if I was studying the impact of coffee on mood or even memory, I would expect the people in the coffee condition to score higher than the people in the control condition. And actually, research shows that that's true. So yay, coffee. So just going back to this bar graph, I do want to briefly explain what stereotype threat is. Stereotype threat is the research that has shown that when you experience, when you're reminded about stereotypes, when stereotypes are cued about an aspect of your identity, now that could be gender, being female, that could be ethnicity, being Latino, being Black, being Asian, being white, it impacts your performance on an activity. So just to give you an example of how stereotype threat might impact performance, in some situations, and I'll include a video separately so you all can actually see this experiment, but in one experiment, they found that when Black athletes were given a test that was said to measure, I think it was sports planning, it was more on the strategy side of sports, and it sounded a little bit more cognitive in a way, more, that's the best I could describe it. when it was described in this way, when it was designed to measure intelligence and planning, black athletes did worse when it was described that way than when they were given the same exact test, but without that prompt. Now, when the same test was given to white athletes and they were told, this is a test of planning or coming up with strategies, the white athletes did pretty well, especially compared to the black athletes because of stereotype threat. But when the test was given to white athletes and they told the white athletes it was a test of performance, of like something like raw athletic performance, maybe not raw, but of athletic performance, the white athletes did worse. So you see that there are stereotypes about all ethnicities, all genders, and there's stereotypes about driving. And when individuals are reminded about these stereotypes, this is stereotype threat. When you're thinking about that, it's taking up some mental capacity, or cognitive load is the term they use. And it makes it, you can imagine, if you're worrying about something else, you're going to do worse on that test because you're already stressed. You're already worried about this test. Now you have this other thing you're worrying about. You're not going to do as well as you would have done otherwise. So when you compare individuals, black participants, same level of capacity, same GPA, matched on every level, they'll do worse when you remind them about stereotype threat than when they don't experience that. You can also experience the inverse of this. Now you have this idea that there's a positive stereotype, right? Asians are good at math. Supposedly positive, right? But in the studies, what you find when Asian participants are reminded of this stereotype, they actually do worse than the control group, right? So even this positive stereotype has a negative impact on ability in some situations. So that's what stereotype threat is. Take a look at the video so you can get a visual of what this is. Just keep in mind that they're comparing white athletes to black athletes, but they're also looking at the black athletes and how they perform within the black athletes, how they perform when they have the stereotype threat and when they don't, right? So keep that in mind. There's different comparisons that are going on. Pay attention to that. Okay, so you have to establish covariance. Now, one thing to keep in mind is you cannot establish covariance if you don't have two groups. Why is that, right? Why can we not establish covariance when you only have one group? It's actually very simple. Look at that bar graph on the bottom right. That's the score I have. Can I say that's more or less than another group? Can I say the score is higher or lower when stereotype threat is there than when it's not? I can't. And I can't because I don't have that comparison group. I have that comparison group. Now I can say when stereotype threat is there, people tend to score lower than when it's not. When stereotype threat is there, women tend to do worse at math than when it's not there, right? These are the kind of statements regarding covariance I can make when I have a comparison group. I don't have that comparison group. I can't say anything about covariance. So keep that in mind. You need covariance to be able to make these statements or even look at did I say you need covariance? You need a comparison group, right, to be able to make any statements regarding covariance. So keep that in mind. You need two groups at least. Now, regarding temporal precedence, you need to establish that your IV came before the DV. Seems pretty simple, right? You need to establish that you expose participants to stereotype threat before they took the math test. You need to establish that you expose participants to caffeine before you measured memory, right? You have to show that in your study design, right? Now, there's some situations, not in an experiment, in a different type of study where you're looking at correlations where you might not be able to establish which came first. You might be comparing people's habits regarding drinking coffee and memory, but you're asking them to self-report, and you can't, how do I say this? Maybe that's a bad example. Okay, this is better. Anxiety and drinking caffeine. Does drinking caffeine cause anxiety? Now, if you have people do a survey and you ask them, well, how anxious do you feel? 9 out of 10. They have a bunch of questions. One person gets a 9. Do you drink a lot of coffee? Oh yeah, you drink a lot of coffee. In this situation, can you for sure establish that they started drinking coffee before they started feeling anxiety? You can't. In a lab setting, you can. You can find people who drink about equal levels of caffeine. You can measure their anxiety beforehand, and then you could give them a cup of coffee and see how their anxiety changes after you give them coffee. Right? So it's not so much the IVs or DVs that determine whether you satisfy this requirement. It's the actual design of the study. So keep that in mind. You have to look at the study, read how it was designed, how is it carried out, and see, did their manipulation of the IV come before the DV? Now keep in mind, it has to be a manipulated IV, meaning that they chose who gets caffeine, who doesn't. They chose who gets to be exposed to stereotype threat and who doesn't, right? Who goes into the control group. So just to give you an example that you might get on the exam, where you might have to read through it and kind of infer, analyze and see, are they satisfying this requirement? Here's an example. One thing I'm going to restate is that last statement. So keep in mind, if you're reading along, just keep in mind for that last statement, I'm going to tweak it a little bit to make it a little bit clearer. Okay, so here I'm asking, is this a true experiment? Whenever you hear true experiment, the person is referring to an experiment that can lead to a causal claim. An experiment where the researcher manipulated the variable, the IV specifically, right? The IV is what they're claiming causes a DV. Okay, so a researcher finds fat mice in the field at 30% body fat and finds other mice at 10% body fat. Okay, and then he compares those mice to to see how well they can complete a maze, and he finds that the 30% body fat mice actually tend to do better. So he concludes, okay, here's where I'm going to make this last statement stronger. He concludes that fat must have a connection to intelligence, and actually stronger than that. He claims that fat improves intelligence, causes an increase in intelligence. Okay, so that's a causal claim. I'm making the claim, or the researcher is making the claim, that fat increases intelligence. That's the claim. The first thing you want to look at is the design of the study. Actually, the IV. So the IV is fat in the mice. I haven't said here the IV is fat in mice, but you should be able to see that if I'm comparing these two groups, and the only thing that varies between the groups I'm highlighting is the fat, then that's the IV, right? Now I'm comparing these two groups of mice based on fat. Now look at that independent variable. Did the researcher manipulate that variable? Meaning, did they choose which group got to be fat or at 30% and which group got to be at 10% fat? Or did they already come that way? If they already came that way, meaning they didn't decide to get them to 30% fat and get some to 10% fat, if they already came that way, then it's not manipulated. So in this case, you do not have a manipulated variable. The mice were already at 30% body fat, and some were already at 10% body fat, right? So here, let me show you why this matters. So this is going to matter because but what if the 30% body fat mice are just smarter to begin with? So they're better at getting food, they're better at finding food, they're better at hunting animals, right, insects. So because of that, they're at 30% body fat. So it's not so much that body fat makes you smarter. Maybe they were already smarter to begin with, and because they were smarter, they ended up being at 30% body fat at a higher body fat percentage than the other mice. So that exposes a flaw, right? They're claiming that, no, it's fat that leads to more intelligence. No, maybe maybe they were already smarter to begin with, and that's why they're fatter, right? So hopefully you can see how that throws into question temporal precedence, which one's causing which, and also key, we do not have a manipulated variable, and you need that. So practice going through that example, practice going through the examples at the end of the chapter. Now, internal validity is the idea that there is an alternate explanation to the relationship you're claiming. You're claiming that your IV is causing your DV, that fat is leading to higher intelligence, is increasing intelligence. But if I can provide an alternate explanation, I've challenged your internal validity, right? So internal validity is the ability to rule out any alternate explanations to the relationship you're seeing between the IV and DV, right? You want to rule out every alternate explanation.